Alright, this video is for section 2.7 on synthetic division, and we'll be using the synthetic division a lot in section 2.8. So I think it's important that we understand how to do it and how it works. So the first thing I'm going to do is I'm going to go through an explanation of why synthetic division is a substitute for polynomial long division. And this is in the textbook in section 2.7. If you're not interested in that, you can skip forward in the video and just look at how to do the problems. But I find that a lot of people it helps people to understand how to do something if they know why it works and what's going on. So let's just go ahead and look at the example. This is on page 120 in the textbook, and this is a polynomial division problem. And we start out with, let's see, we're dividing 2x to the fourth minus 6x cubed minus 23x squared plus 16x minus 5, and we're dividing this by x minus 5. So first off, the fundamental question that we're asking in a problem like this is, what do you multiply this thing by to get this answer, right? That's what division talks about, right? When we do 12 divided by 4 equals 3, that's because 4 times 3 equals 12. This is the fundamental relationship between multiplication and division. So what we're saying is that we want an answer up here so that when we multiply it by x minus 5, we get the thing that we started with. So that's our goal in this situation. So first off, you look at the highest power of x here and the highest power of x here, and we need a coefficient of 2, right? And then we also need to multiply by x to the third. So that when we go 2x to the third times x, we'll get 2x to the fourth. But now in this multiplication that we're setting up here, this 2x to the third is going to be distributed both to the x and to the minus 5. So we're not just going to get the 2x to the fourth, we're also going to get minus 10x cubed. Okay, now the long division process says we want to subtract this piece from what we've got up here. Now, the reason why we do that is because we want to match everything that's up here. This is what we're getting from the multiplication. So when we subtract, this will tell us what else do we need. I'll talk about that more as we go through this. So if we subtract here, that'll make this minus 2x to the fourth. That'll make this positive 10x cubed. So these cancel out, right? That's because when we multiply this times this, we get exactly what we need. The problem here is that when we multiply this times the 5, we don't get minus 6x cubed, we get minus 10x cubed, which means that we're going to need a positive 4x cubed to bring us back down to the negative 6. Okay? Now we'll bring this down. And then we just run through this process again. What do we need to multiply this x by to get this 4x cubed that we're going to need? Okay, let's see, we're going to need a positive 4x squared. So then that'll give us 4x cubed here, and then when we distribute it to the 5, we'll get minus 20x squared. And then we subtract to see what else we're going to need. Here, we don't need anything else because we set it up that way. Over here, we're going to have a negative 20x squared, but we need minus 23x squareds. So that means we're going to need another negative 3x squareds. So that means we need to multiply by minus 3x. And then that'll be positive 15x. When we subtract to see what else we need, we don't need anything else here. Good. Over here we're going to need a 1x. And then also a minus 5. And that'll put a 1 over here. And this divides in nice and evenly without any remainders. Okay? So what we're saying in this problem is that x minus 5 times 2x cubed plus 4x squared minus 3x plus 1 will equal this polynomial that we were dividing into. 2x to the fourth minus 6x cubed, 23x squared, plus 16x minus 5. All right, and if we do this multiplication, then you can see this sort of playing out here. Okay, now let's back up and talk about a shortcut method for doing this. Okay, so this was our answer right here. And this shortcut, the synthetic division, is set up to work for dividing by something that's in the form of x minus a. X to the first minus a. That's what this is set up to work for. And in most situations, we're going to need a 1 here as well. Okay? So given that understanding, that means that our answer will always be 1 degree less than what we're dividing into. Okay? Let's see here. So the reason why that's important is because then all we need to know are what are the coefficients for these powers of x, right? If we know that we're going to start off with an x to the third here, we just need to know how many x to the thirds are we going to need, right? And then when it comes to the x squareds, how many of those are we going to need? So really, if we knew these numbers, then we would have our answer. Okay, so the question for synthetic division is, where do these numbers come from? All right, so let's go through here and look at where are these numbers coming from. The 2 comes right from the first coefficient in what we were dividing into. Okay, because if this is a 1, then you're going to need a 2 here to produce this 2 here. Okay. Then where does this positive 4 come from? Well, what we did was we did 2 times negative 5, changed the sign, and then did 10 minus 6 gave us the 4. Okay, so that's where the 4 comes from. Then where did the negative 3 come from? Well, we did 4 times negative 5, changed the sign, and then did positive 20 and negative 23 makes negative 3. And then this last coefficient here, the positive 1, that came from doing negative 3 times negative 5 makes 15, change the sign, positive 16 and negative 15 makes positive 1. And then this remainder of 0, I mean, I'll put it up here because not everything's going to have a remainder of 0. But the remainder, again, is going to come from 1 times negative 5, change the sign, positive 5 and negative 5 makes 0. So, synthetic division is set up. What we do is we pick off the coefficients of what we're dividing into. And if there's a missing power, it's important to put a 0 in there. I'll show an example like that when we get to the problems. But we start off just by taking out the 2, negative 6, negative 23, 16, and negative 5. Okay. Now we take the value of what I called A here a few minutes ago. In this case, it'll be 5. And the reason why we take a positive 5 when this says minus 5 is because notice how we had to keep changing the signs all the way through here. The synthetic division changes the sign at the beginning so that we don't have to do that. Okay? So again, where does this first coefficient come from? Well, if this is a 1, it's going to match the first coefficient in what we're dividing into. Where does the 4 come from? It comes from 2 times 5, and then add it to the negative 6. 2 times 5 is 10. 10 minus 6 is 4. Where does the minus 3 come from? 4 times 5 combined with the minus 23. 4 times 5 is 20. Positive 20 and negative 23 makes negative 3. Where are we? Where does the 1 come from? Negative 3 times 5 makes negative 15. 16 minus 15 is 1. And then to know the remainder, you go 1 times 5. 5 and negative 5 make 0. So there's our remainder. And these are the powers of x. Technically, this is x to the 0 power, x to the first, x to the second, and x to the third. So there's our answer. 2x to the third plus 4x squared minus 3x plus 1. Okay? All right, let's look at one more example like this. This is also an example in the textbook. This one that we just did was on page 120. This next example is over on page 123. So let's take a look at that one as well. Okay, on page 123, this problem is 3x cubed plus 5x squared minus 9x plus 9, and we want to divide that by x plus 3. Okay, so we'll go ahead and do the long division here again. We're going to need a 3x squared, and then when we distribute, we'll get 3x to the third plus 9x squared, and then we subtract to see what else are we going to need here. This cancels out. Here we're going to need another negative 4x squareds. So that means we need to multiply by minus 4x. There's our minus 4x squared. Then we'll also get a minus 12x. And then we subtract to see what else are we going to need. These cancel out. Here we get a 3x and then bring down the 9. And this says we're going to multiply by 3. And there's our 3x plus 9. This is set up to have a 0 remainder as well. Okay, now let's do this by synthetic division. First, we pick off the coefficients for all the powers of x. So we're going to have 3, 5, negative 9, and positive 9. And then remember, we need to change the sign of this at the beginning so that we don't have to keep changing the sign throughout the problem. So this says x plus 3. That means we're going to do our synthetic division with a minus 3. Where does this 3 come from? It's the same as what we're dividing into. So this comes straight down. That's our first coefficient. And then we go 3 times negative 3 is negative 9. 5 minus 9 is negative 4. Negative 4 times negative 3 is positive 12. 12 minus 9 is positive 3. 3 times negative 3 is negative 9. 9 minus 9 is 0. That's our remainder. Our answer here is 3 is the constant term, minus 4x is the x term, and 3x squared is our x squared term. And there's our answer right there. Okay, so let's take a look at some problems for this section. Let's see here. These problems are over on page 127. Okay, so problem 2. Let's see, we've got x cubed plus 5x squared minus x minus 14. Well, I'll go ahead and write this down because I do want to say a few things about it before we start in on the problem. Okay, so first off, double check that you've got all the powers of x. 3, 2, 1, x to the 0 power. Okay. So that means we can just strip off these coefficients, 1, 5, negative 1, negative 14. And here we're dividing by x plus 2, so in synthetic division, we'll use a minus 2 to go through this process. This coefficient comes straight down, then we go 1 times negative 2 is negative 2, 5 minus 2 is 3. 3 times negative 2 is negative 6, minus 1 and minus 6 make minus 7. Minus 7 times minus 2 is positive 14. We get a 0 remainder, so this divides in evenly. Put in our powers of x, and our answer here is x squared plus 3x minus 7. Okay. Let's see here. Let's look at problem 4. Problem 4, x cubed minus 10x squared plus 23x minus 6, and we're dividing by x minus 3. Okay, same process. Double check that you've got all the powers of x, and then just take the coefficients. 1, minus 10, 23, and minus 6. And then here we're dividing by x minus 3, so we'll use a positive 3 to do the synthetic division. This coefficient comes straight down. 1 times 3 is 3. Negative 10 and 3 is negative 7. Negative 7 times 3 is negative 21. 23 minus 21 is 2. 2 times 3 is 6. And this divides in evenly again. And our answer here, x squared minus 7x plus 2. And you can always double check your answer by multiplying this times this and seeing, oh, do we get what we're looking for? I'll go ahead and check this one. I won't do this for every problem. Let's see here. So, if we distribute in here, that'll give us x cubed minus 7x squared plus 2x. Then minus 3x squared plus 21x minus 6. And here it is, x cubed minus 10x squared plus 23x minus 6. Okay. Let's see here. What do we want to do? Let's do problem 6. We've got x to the 4th minus 3x cubed plus 4x squared minus 36. And again, we're dividing by x minus 3. Okay, so first off, let's make sure that we've got all the powers of x, 4th, 3rd, 2nd. We're missing the x to the 1st power, okay? So there's like this hidden plus 0x in there, and then minus 36. So when we make our coefficients, 1, minus 3, positive 4, then we need a 0 for that missing x term, and then the minus 36. Because if you don't have that 0 in there, it messes everything up. Okay, so we're dividing by x minus 3, and so again we're going to use a positive 3. So then we get 1. This makes a 0. 0 times 3 is 0. 4 and 0 makes 4. 4 times 3 is 12, so that's a 12. 3 times 12 is 36. And so we get another 0 remainder. And this divides in evenly. And our answer here is x to the 3rd plus 4x plus 12. And we can leave out that 0x squared. Okay? All right. That's problem 6. Let's see here. Let's look at problem 8. Problem 8. X to the 4th minus 16x squared minus 5x minus 24, and we're dividing by x plus 4. Okay, let's see here. So, make sure you've got all the powers of x. 4, 3. We're missing the 0x cubes here. And then squared, 2, 1, 0. Good. So now with the coefficients, we're going to have a 1, 0, minus 16, minus 5, and minus 24. And then we're dividing by x plus 4, so we'll use a minus 4 in the synthetic division. So the 1 comes straight down. 0 minus 4 is negative 4. Negative 4 times negative 4 is positive 16. The negative 16 and positive 16 make 0. 0 times negative 4 is 0. Negative 5 and 0 is negative 5. And negative 5 times negative 4 is 20. So this gives us a remainder equal to negative 4. Okay? So this is x, x squared, and x cubed. And so our answer here is x to the third minus 4x squared minus 5 with a remainder of negative 4. Okay. Now if we want to check this answer with the remainder on it, it works in a similar way to checking your answer. I don't know if you remember checking your answer for long division when you learned how to do that. That means you multiply these two and then add this negative 4 on there. So let's see what we get when we do that. And then with a minus 4 should give us what we started with. All right, so this will be x to the fourth minus 4x cubed minus 5x, and then plus 4x cubed minus 16x squared minus 20. So that'll be x to the fourth. These cancel out. Minus 16x squared minus 5x minus 20. And then this last minus 4 will give us that 24 that we wanted there. Okay. Now, we need to talk about problems 10, 12, and 14. So these work a little bit differently. So I'm going to go back to this example on page 124. So what we've got here, this example is 6x to the fourth plus x to the third plus 9x squared plus x minus 2, and we want to divide by 2x plus 1. Okay. So, first let's double check that we've got all the powers of x. 4, 3, 2, 1, 0. Good. So we'll put down our coefficients. 6, 1, 9, 1, minus 2. Okay. Now, this thing doesn't have a 1 in the front. Remember, at the beginning I said that the synthetic division is set up to divide by 1x to the first minus a. Okay? So technically, we can't really do this process with that 2x plus 1. But we can work around it. Okay? So, remember that we always change the sign for this thing when we were going to divide here, right? So if we were dividing by x minus 3, we used a positive 3 in the synthetic division. Here, if we want to do the synthetic division with 2x plus 1, we can do this if we use negative a half. Okay? I'll talk more about this after we go through the process. Okay? I'll try to talk about what is happening here and why does using the minus 1/2 work for us. All right? So let's go ahead and do it first, and then I'll talk about how to get the answer out of this. All right, process is the same. 6 comes straight down. 6 times negative a half is negative 3. That'll give us negative 2 times negative a half is positive 1. There's 10. 10 times negative a half is negative 5. Negative 4 times negative a half, positive 2. And so we get a nice 0 remainder here. Now, before I go on, notice that all of these numbers down here have a common factor equal to this denominator of 2 right here. Okay? So what's going on here? Well, let me put the powers of x in here. X, x squared, x to the third. So the answer to this question right here is not 6x cubed minus 2x squared plus 10x minus 4. Okay? I mean, you can see that if you did the long division, your first coefficient should actually be a 3, right? So, what is happening here is what we're saying is that x plus a half times 6x cubed minus 2x squared plus 10x minus 4 is equal to 6x to the fourth plus x cubed plus 9x squared plus x minus 2. That is true. Okay, but the question was asking, what is this thing divided by 2x plus 1, not x plus a half? Well, the way to transfer this into an answer to this question is to take out this common factor that I mentioned a minute ago. So, if you factor out the 2 here, then you'll have 3x cubed, 1x squared, 5x minus 2. Now, multiply that 2 back in there. And as it turns out, what do you have to multiply 2x plus 1 by to get what we were dividing into in the first place? This thing, 3x cubed minus 1x squared plus 5x minus 2. So this is our answer right here, okay? So 3x cubed minus 1x squared plus 5x minus 2. So that's the process that we can use to divide by something that has a coefficient other than 1 in front of the x, okay? And the key here, you don't have to go through this process every time. All you really have to do is take your answer and pull out the common factor, and that'll give you the answer that we're looking for. Okay, so let's go back and look at those problems in the exercises. Let's see, what page were we on over here? 127. Okay, so problem 10 on page 127. We've got 3x to the 4th plus x to the 3rd minus 3x plus 1, and we're dividing by 3x plus 1. Okay, so for starters, let's pull the coefficients out of what we're dividing into and make sure that we've got all the powers of x here. 4, 3, 1. We're missing the x squared. We've got a 0x squared there. So we're going to need 3, 1, 0, minus 3, and 1. Let's see here. So, if you're not sure what to use for the synthetic division here, that process that I was doing over here on the side a few minutes ago, set it equal to 0 and then solve for x, negative 1/3. So that's what we're going to use to do our synthetic division. And this is the same thing that was happening up here, is that this is the difference between x plus 1/3 and 3x plus 1, okay? This common factor of 3 is going to be down here in our answer in a few minutes. So let's put the first coefficient down here. 3 times negative 1/3 is negative 1. That makes 0. 0 times negative 1/3 is 0. There's another 0. 0 times negative 1/3 is also 0. Minus 3 and 0 is minus 3. And then minus 3 times minus 1/3 makes 1. And that gives us a remainder of 2. Okay, so these are the powers of x. So, what is our answer here? Well, this answer says 3x to the 3rd minus 3. Well, we need to pull that factor of 3 out there, and that'll leave us with x to the 3rd minus 1. Okay, so that's our answer over here. X to the 3rd minus 1 with a remainder of 2. Okay? And that's going to give us what we were dividing into. Okay? So, let's check our answer here. So, we want to take 3x plus 1 times x cubed minus 1. And then add, oh, I left off the remainder here. Yeah. Add on our remainder, and then that'll give us what we started with. So x cubed minus 1, and then the remainder. So this will be 3x to the 4th minus 3x plus x to the 3rd minus 1 plus 2. So 3x to the fourth plus x cubed minus 3x plus 1. There it is. Okay, so that's problem 10. We'll do 12 and 14 to finish up the section here. Okay, problem 12. Let's see here. 6x to the fourth minus 7x cubed plus 5x squared minus 17x plus 10. And we're dividing by 3x minus 2. Okay, so do we have all the powers of x? 4, 3, 2, 1, 0. Good. So that means we need 6, negative 7, 5, negative 17, and 10. What do we divide by here? Pull out the 3 or set it equal to 0 and solve it, right? 3x minus 2 equals 0. 3x is 2. X is 2/3. That's what we divide by. So 6 times 2/3, and feel free to use your calculator for this. It's faster for me to do it without the calculator when I'm working at the board here, but there's nothing wrong with you using your calculator there. Let's see, so 6 times 2/3 will give us 4. 4 and negative 7 is negative 3. Negative 3 times 2/3, negative 2. 5 minus 2 is 3. 3 times 2/3 is 2. Negative 17 and 2 is 15. 15 times 2/3, negative 10. And there's a nice remainder of 0. Notice we've got a common factor equal to this denominator. So our answer in this problem is going to be, well, I'll write this down. And then we need to factor out a 3. So this will be 2x cubed minus x squared plus x minus 5, 0 remainder. So there's our answer. 2x to the third minus x squared plus x minus 5. All right, let's look at one more problem. Okay, problem 14. Let's see here. 3x to the fourth minus x to the third minus 21x squared minus 11x plus 6. And we're dividing by 3x minus 1. Okay, so 4, 3, 2, 1, 0. We've got all the powers of x. So our coefficients are 3, negative 1, negative 21, negative 11, and positive 6. And what are we dividing by here? You can always set this equal to 0 if you're not sure. X is positive 1/3. Okay. So 3 times a third is 1. That'll be 0. 0 times a third is 0. Negative 21 times a third is negative 7. Negative 18 times a third, negative 6. There's a nice 0 remainder. So this says 3x cubed, 3x cubed minus 21x minus 18. Notice we've got a common factor equal to that denominator. Factor out the 3. And our answer is x cubed minus 7x, minus 6. Okay, so that's it for this section, 2.7. So please do the odd problems in this section, and then our next video I'll split this in 2 pieces in section 2.8, and that'll do it for chapter 2. And then once we get through that, we'll move on to chapter 3. So, as always, if you have any questions, please let me know. I'll be happy to work with you to try to help you to understand this. You can also contact Kelly Musgrove. She's running a virtual math lab, and we're happy to help you in any way that we can.